Welcome, everyone. Today is Monday, June 2nd. This is week 9, day 1 of Hotel Evening and Weekend Platoon. Today, we are going to cover SQL queries. Um, so let's jump straight into it. Actually, before I jump straight into it, you guys covered a bunch of Docker stuff over the last week, right? Docker is really, really important. You can build a career on Docker alone, being good with it. So that's something that's going to be pretty consistent that you learn within the program and that's actively used and will be actively used in the field for, I would argue, for the foreseeable future. Make sense? All right, so keep that in mind. Super important. Okay, now that we said that, we're going to talk about SQL queries. But before we jump into it, we'll be executing queries against the CARS database. So if you go to it, actually, I already had it opened. You can see my screen, right? Clone this right here. Clone this right now and run these commands up to psql-h localhost. And you should see something that looks exactly like this, right? You should be inside the CARS database shell. So you need to get in here at the moment. And if you notice your Docker doesn't start, it's because your app's not open. That happens to me all the time. I always forget to start it. All right, so I'm going to pause the recording. You guys are going to load up your Docker shells, your connection to the Postgres server, and we're going to start from here. Let me pause this. Not pause share, but pause recording. Okay, can anyone tell me what SQL is?
Structured query language.
Yeah, it's just a querying language. What does that mean in just layman's terms? You query data with it. That's it. And it's arguably the most powerful querying language. And it's arguably one of the very few things in programming that hasn't changed in like 40 years. Um, it's been more or less the same. If you bought a SQL book 30, 40 years ago, it'd be more or less similar. One of the very few things. So you have that, right? So you query data. Why is querying data important, kind of in a macro sense?
So
I
you can
guess,
find it.
yeah, but you query data so you can find it, obviously. But what would be some use cases for it? Why is it important that you can query data?
So that you can manipulate it and change it, update it.
Yeah, right. For all of those reasons, right? And ultimately, being able to store data that is persistent is how you build big applications, right? We don't want people to create a new account every single time they go to Facebook, right? They can just log into their previous account and all their information is saved. Persistent data will be able to query it, right? It's really powerful. Okay, so it's a querying language. It's not a programming language, it's a querying language. And this is the kind of like the superset of everything, right? Eventually, if you really get deep into it, then you start getting flavors of SQL like PL SQL and a couple other things that I really want to get into, right? But this is kind of just like the OG granddaddy of querying languages. Does that make sense? Yes? Okay. Super powerful. Let's look at the terminal and let's try to read it line by line because this is important. You're not just punching in commands that don't mean anything, right? Uh, what is this commit ran telling Docker to do? Just roughly. You don't have to read it, character by character. You could, but I just asking the general sense. Can you read this?
It's telling it to run a file. Take it by the name of runner, uh, and then it's connecting to it looks like Postgres with password that equals password, and then it's saying to use the cars DB
Yeah, that's
database.
pretty. Yeah, that's pretty close. I don't want to get too nitpicky in it. That's more or less the same idea. The idea. Right, it's just telling Docker to run. It's actually telling it to run a container named runner. Right. A lot of the times when you see these hyphens or one hyphen, they're known as flags. Right. And flags is just a parameter. Right. Hey, pass in. Right. This keyword parameter. This. Right. This is RM in programming that stands for remove. Right. It says, hey, remove the container if it's not running anymore. But these are just extra flags, extra commands. Ultimately, it's passing the password in, right? And we want to access the database called cars TP. Yeah, more or less. Then this gives you a container ID. It returns that. I just put clear because I just wanted to clear it. But then I just scrolled up. Then I do Docker PS is just a command that says, hey, show me any containers that are running, right? And notice that this container ID is actually the same as this one. It's just cut off. And that's all you need, right? This is really similar. If you ever do git log and you try to branch off a commit or branch into a commit, you only need like the first 8 or 9 characters. I'm not really quite sure what the official cutoff is because I always just copy the first couple, but you don't need all of them. It knows which one. It's unique enough that it will autocomplete for you. All right, so there you go. It says, hey, container ID here. It's running an image called carsDB, right? A command is just entry port. It was created 6 seconds ago or whatever that was. It's listening on port 5432, and it's a TCP connection. Names the container name, as I mentioned earlier. It's called runner, but that could have been anything. All right, so then I exec into this container, which means I just went into their what? It says it right here. It actually just says it right here. I just execed into a Docker container, which means I went into their what? This kind of gives it away here at the end. I went into their Linux shell. And if they have Debian, if you look down here, that's just a distro of Linux, right? So I said, hey, open the bash shell. And I went into it. And what user am I? I'm root. So I have all the privileges, right? Cool. Then I put in this command that says, hey, connect me to the Postgres server, right? It's running on localhost. It's port 5432. My username is Postgres, right? I want to get into cars. So it goes into cars. Notice I put clear again because I'm used to a bash shell, and this doesn't do anything because the syntax is different within this server, right? And then here DT, I said, hey, show me all the tables in this database, and it shows me everything. And the owner's Postgres. Because that's the owner that you created when you set up your Postgres, probably. You can have multiple owners there. You can set up other users. All right, and these are all the tables. Yes? So effectively, I'm connected to my Postgres server, right? And I can access all the tables. Cool. I think the clear command, and I actually don't use SQL that much, or hardly ever actually. I think it's exclamation mark clear. So I can clear it and then go back to it. And that's what I originally was trying to do. Okay, cool. So we're going to go off of that here. I'm going to make this small. And then I'm just going to superimpose it here. You can just listen or you can kind of follow along, whatever is best for you. All right, so when we go in here, we're going to start querying data from these databases. And actually, if we just go in here, we can look at everything, right, that we're going to be able to query. Right, if I go all the way down here, what do you see here?
Data.
Yeah, you see data and you see, hey, there's a bunch of app users, right? And the command is what? It's a /DT will show me all the tables, right? And notice public, look at the name of this table. It's called app user. So if I was to go into app user, I'm going to see look at this, look at line 56. When I ran all those commands, it loaded my Postgres data. So it's going to load all of these guys, right? And if I scroll down, oh man, this is a ton of data, right? So I'm not going to be able to just go to that. I'm not going to scroll through it. I could just go up here, right? But if I go up here, right, I know that app user, there's a bunch of data for app user. And here's app user right here. These are going to be all the information I can find about app user. It's going to have an account ID, a first name, a last name, email, password, right? And some other stuff I don't really understand. That's fine. Right. So if I actually scroll further down, then I'm also going to find a table called user profile, right? And I'm going to find even more data if I was to scroll down. I'm not going to because I don't know how many lines this is, but I could, right? And then I go down here and there's also going to be car model, right? This code right here is actually creating it. A table called car model. And then down here, it looks like I'm going to insert a bunch of data. Yep. All right. So the core of retrieving information from SQL database is the select command, right? You're going to see things that are capitalized in terms of the querying language, and this is the querying language. But just so you know, it doesn't have to be capitalized. It's going to read it just the same, right? So let's look at a specific table. Let's look at car because that's just easy, right? Table name is not actually a name of a table, so you remove that, and I'm just going to put car. Really important, put a semicolon at the end. If not, it's going to read it as like a multi-line command. Right. So when I do select star from car, it's saying, hey, give me everything. Remember, star in programming is a wildcard. Hey, give me everything from the table car and list it. That's what I'm asking. So let's see if we get a lot of information here. What happened here? Oh, I had a syntax error because I tried to do clear. Doesn't matter. Let's try that again. Select star from car. I should get everything from car, right? There you go. Got everything from car ID. I got number of owners for this specific registration number. I got the manufacturer year, number of doors, car model, mileage, right? I can scroll down. I don't know how long that's going to be, so I'm not going to, right? But you can press Q. You see bottom left-hand corner, the colon. I can put Q. It gets me out of that, right? So that's the select everything from this table and show it to me. Yeah. This returns all the rows and columns of a particular table. I just said that. But you can reduce the amount of data that you retrieve, right? You can do this right here. Let's do that command again. And let's just pick two columns, right? If I run that, I know that I have manufacture year and mileage. Why don't I just grab those two columns? You see that? Manufacture year, I know is a column name, and mileage. So manufacture year and mileage. Okay. Let me go back. Now I'm going to just copy this, right? But column 1 and column 2 is just an example, right? What were the two columns that I wanted? Mileage was one of them. And what was the other one?
Registration?
Registration. Was it registration year? Did I spell mileage right? I guess we're going to find out. Okay. So if I do this, what do you expect to see once I hit enter?
Both columns of information, I think.
Yeah, both columns of information, and that's it, right? Because now look at my thing. It's not wildcard star anymore, right? It's just registration year and mileage from table. Table name is nothing. I don't have that table. So let's go car again, colon. And let's see if we just get the two columns here.
It was registration number.
Registration number. Good catch. All right, let's try that again. It's not registration year, it's registration number. Okay. That's how we threw the error. Let's try it again. There you go. So there you go. I got those two things on. Perfect. So you don't have to grab all the information if you just need a little bit of information, right? You can also restrict it, right? So let's go with that same command that says, hey, you can do the limit from car, and then you can start putting like conditions on the data, right? So, hey, let me get registration number and mileage from car, limit 3. I'm not going to do limit 5, I'm going to limit 3. So capitalizing is convention, but just know I don't have to. Notice my limit's not capitalized. This still should work. It's case insensitive, even though you'll see it like capitalized all the time. So if I run this, I'm only going to get how many rows?
You're only gonna get 3.
Yeah, there you go. I got my registration number and my mileage, and I limited it to the first three. Cool.
Is that always going to limit it to the first three, or can you limit it to other, like only three different columns?
You can limit it to however you want, and then eventually you can put conditions, right? You can sort lowest to highest, give me the three greatest, give me the three lowest, right? Take the average and give me three above, three below. You can start getting real, you can string together a really long query if you need. Right? Cool, 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 cool. Go ahead, Art.
Yeah, I think I still have like the API and Postman stuck in my head. Is with these type of queries, I know we can see the data here, but is there any advantage to going into Postman, or can we use Postman to look at the data before we use it?
No, Postman has nothing to do with this at all.
Okay, okay.
Here, we're just querying data. We're just querying data in our local Postgres instance. Now, you can extrapolate that on how APIs end up working, right? Query parameters being sent through an API, right? They get manipulated and structured into a SQL query, and it pulls the data from the database, packages it, sends it back in JSON, populates your GUI. So that happens, but that's not what this is about at the moment. That is the right idea, though, in the grand scheme of things, how things work. Right? You ever forget your password and you have to reset your password and ask you what's your oldest sister's middle name and what elementary school you went to and what childhood street you grew up on? Right? They're querying that data. And don't think behind the scenes, depending on how big the database is, they're not stringing together a SQL query with your information to validate your identity.
You just
I
hope
get
it's
it.
not stored in plain text.
Yeah,
Which
exactly.
is
Right? That gets encrypted, right? SSL decrypted on the back end, right? There's a bunch of different levels of encryption or different kinds of encryption. Make sense? All righty. So that's limit 5. Try retrieving only account ID, first name, last name from app user table. You should see an output like this. Okay, so it's asking to get these from app user. So that's easy. We're going to select these three. I'm just going to paste them right there. From where? From app user. Is that my table? Let me look above. Yeah, app user. Right? And I wanted to limit to the first 5, right? That's what I wanted. So this is a query. Hey, give me account ID, first name, and this is a typo here. This is English, but this is not SQL query, like SQL query language, right? That's a comma there. You can't do and. So there you go. I'm going to select account ID, first name. Why is there a K there? First name, last name from app user, limited to the first 5. That looks right. Is that right? Yeah, that's right. That's what I needed. You should get in a habit of only requesting data that you need. So this is actually a really important point here. Why should you get in the habit of only requesting data that you need?
Computing,
Yeah.
memory.
Yeah, all those things. And all those things really just translates to money. If you keep making really expensive calls, you're burning cash. Right? If you return 1 million elements, but you needed 3, how much extra resources did you burn? Not very efficient. And at scale, that adds up. All right, so here's another one. We gave you the keyword limit. We gave you the keyword select, right? Here's the next one, where conditions. Most of the time, you don't want to indiscriminately fetch everything from a given data. Again, way too expensive, not efficient. Filtering by different condition is an important part of learning how to use SQL, right? General syntax is select star from table name where, right? Column, name of column, whatever it is. operator value, right? So then you can start getting into your operators, descriptions. You already know these, not going to show them to you, right? But here's a good example of it, right? Let's look at the first one because that's a really common one. Select star, give me everything from students where the first name is Andre. So it's going to pull from the table students every single person who has a name, the first name Andre, right? Can be Andre Miller, Andre Rodriguez, Andre, some middle name, Vasquez, whatever, right? Because their first name meets that criteria, so it's going to pull it, right? Yeah.
Are you able to get a query like list me all these things in like alphabetical order? Does it
Yeah,
go
you
that
can.
deep?
Yep, it
Oh,
does. It goes deeper than that. Yeah. Here we go. I'm gonna pause this. I'm gonna share something with you. I don't necessarily want this recorded. Okay. So there you go. So that's an example that I gave you. Um, so these all you understand that between values also a key word here. This just gives you a range, right? Between 3 and 4, right? So it'll give you 3 and 4. I mean, that's actually shitty, a crappy example. It should have been like between 3 and 6, right? That's the definition of between, but same idea, right? Here's a good one. Like, this is a pattern match with a wild card. This is really, really useful. It's like a regex, right? It says span. So anything with the prefix span, you can do suffixes as well, right? You can do just character match, regardless of where it is in this specific column. As long as those 4 characters match in order, return it, right? Match against a list of values. This is a good one. Select star from enrollments. I'm recording again. Okay, good. Where grade in A or B. Give me all your honor roll students for this specific class, right? When a single operator isn't enough, you can combine them with and or, right? Let's get everyone whose first name is Art, right? I could literally just copy and paste this. Let's try it. Select star, give me everything from app user where first name equals Art. Let's see how many users have a first name of Art here. Only one. And there you go. It gives me their kindie, their first name, their last name, your email, and just a random password, right? So here, this is kind of if this was a real database, you wouldn't have this password. This would be a hash, right? And then you would need extra special permissions for the whatever the encryption method is to then decrypt it, right? And then whoever decrypted or got the key, that would be logged in some kind of audit trail. So it shows, hey, this person's account accessed this decryption key at this time and used it on these rows, right? That's a little bit outside the scope of this, but just know that this wouldn't really happen. But that's just for your understanding. Go ahead, Art.
Yeah, well, I raised my hand a lot because I don't want to break your flow or break your
Oh, no
talk.
worries.
So I'm still stuck on JSON API. I apologize, but like when we were extracting the JSON from an API, we still had to convert it. It was even though it was JSON being brought down, we had to convert that to use that. What type of format are we getting here? Is it just a database? And once we receive the database, do we have to format it to use it, or does it come across clean?
Yeah, you're going to have to manipulate it, right? Once it's returned from your database, it's going to become in a specific structure, right? Then you're going to have to manipulate it / package it and send it in whatever form you need, right? Or you can accept it in the form that it's packaged and then just pull whatever information you need, which should be pretty much all of it. If not, why'd you call it, right? You don't want to pull information you're not going to use. There's no point. And again, here it's 10 items, 100 items, right? But real database will have millions, will have billions of rows, potentially tens of thousands of columns, maybe less. Make sense? Right? There has to be certain database within Facebook and Instagram and TikTok whose rows probably number in the hundreds of millions. Probably. Right? Okay, so that's art, and we got exactly what it is here, right? It's only one person. Notice that a single quotes around the string art. In SQL, double quotes are optionally used for column names. So when you're doing where a first name, just use single quotes, FYI. This terminal is not that forgiving for Postgres, so if you screw up, it will let you know. All right, so what if you only wanted to use users with emails that ended in .com, right? Remember I said you could use prefixes or suffixes, right? This is an example of a suffix here, right? I put a little colon at the end, select star, give me everything from the table app user where the email is like .com. Obviously, that's a ton of them because I can't think of that many emails that end in anything but .com, right? That wasn't particularly helpful, but you get the idea. All righty, what's more that I want to look at right now, sometimes you don't care that much about particular values, but instead are interested in the bigger picture. Aggregate functions. This kind of gets into a little bit of what Adam was mentioning earlier. So far, we've just been selecting individual rows, but you can also aggregate values from multiple rows. Commonly used aggregate functions are min, max, count, sum, average. Let's just say you want to know how many users have emails ending in .com. This is an aggregate function here. Select count. Okay. Select, look at count parentheses. That's an aggregate function that's wrapping star. Give me everything, but I want you to count it. From table app user where email ends in .com, right? So I just want to count all the records here. There you go, 349, I should say. And there you go. If you wanted to select the average, here's your average. Select, remember, average aggregate function. And you can tell it's a function because it wraps, right, that specific column or variable name in parentheses. So select average. Now I know it's an aggregator. An aggregate function from car. I can show you just that right now. Notice how car is capital C and then lowercase, right? Remember, case insensitive, so that gives us exactly what it shows here, 1.956, etc. Okay, you can also combine these where clauses to get more specific results. So notice how we're starting to string things together here. Select average number of owners from car where manufacture year is less than 2008. What is this one telling me? Read this for me. What is this going to return?
Every car from the manufacturing year over 2008?
Yeah, but it's also getting the average, right?
I missed that.
Look at it. It's the last line right here. Select average number of owners from car where manufacture year is less than 2008. So it's getting all the cars. It's going to eliminate everything that's older than 2007. Okay, it's going to strip the list. Only cars less than 2007. Then it's going to count the average number of owners each of those cars had and return that. So the average number of owners for all cars in the database, year 2007 or less, is 1.8 owners. Almost 2 owners per vehicle. Cool. All right. So that's SQL queries. There's a lot to this. This is really introductory, guys. We haven't got into really fancy stuff like joins. Go ahead, Art.
I just want to make a comment, and maybe you can maybe clarify this. But when you were counting and you were using that wildcard, that was counting specifically the number of rows in the database, which could vary, which could give you a different response. Let's say if you were actually searching by column. So if you said, okay, give me the number of emails, if there's like a null entered in there, you might have 349 rows, but you might only have 348 entries. So just to be clear, we could have a distinction between searching by rows and columns, correct?
Yes, but you're going to have to be very specific. Look at this line right here. It says count everything. So an entry would count in this specific scenario,
Oh,
right? You would have to be intimately familiar with what you're querying to make sense of that. Typically, people querying the information would understand what exactly do they need. And if they didn't, they could just query it and see, hey, are some of these things left blank or are they null? Right? Because you can exclude null from your count if you wanted to. We didn't show you that here, but you can. Right? You would just run an aggregate count, right, on everything from here where a specific column doesn't equal null. Or count all rows as long as every column doesn't equal null.
Okay, cool, thank you.
Yep. I think there was a guy, yeah, I think there was a guy who tried to make his license plate null in the hopes that when his license plate was stored in the DMV like SQL database, nothing would come up. So if he got any like speeding tickets or traffic tickets, it wouldn't be pinned to him because they'd get lost in the database. Ultimately, it didn't end up working, but that was his idea. That's a famous story about it. I think he ended up getting screwed or something. I can't remember. You can read it. This might be it, actually. Yeah, this guy actually, I think the opposite. I think anything that wasn't assigned to anybody ended up going to him or something like that. I don't know. You guys can read it. I'll drop it in the
That's brilliant, but
Slack channel.
that sucked if it backfired on him. I love that idea though. I love
Yeah, that's pretty clever. And this is kind of outside of the scope of this, but as I'm looking for your channel here, because I'm in like a million of them, you kind of start getting into the way the hackers find vulnerabilities in applications through like SQL injections and like DDoS attacks and weird stuff like that. So this was kind of like an amateur attempt to kind of circumvent the way that they store data and kind of get away with things. But I don't know. I just thought that story is kind of funny. Okay. So pretty much the main objective of today is to get really comfortable with SQL queries because you're going to use it a lot in your personal project eventually and in your group project because you're going to use Postgres, right? And the quicker you are with it, just the better. The more familiar you are with it, the better. Like I don't normally do SQL queries, but if you end up in a heavy data engineering job, you're going to use this all the time. That's all they do is manipulate data and restructure how it's stored for faster accessibility, right? And more efficient queries. So let's look at challenge number 1. This is SQL query selecting, filtering, and aggregating. You're going to be answering some questions by writing queries against the CARS database. How many app users are there? Let's go ahead and do the first 2 together, and then I'll let you just continue this. So this is the very first one. All right, so let's see if we can do this one together. So I'm actually already, how many app users are there? How many app users? We have a table called app users, right? What's the command for finding the tables that are available in my database? Oh, I screwed that up again.
/DT.
Yep, /CT. Okay, so here I do have a table called app user. Oh, so it's saying how many app users are there? What would be the command?
Select count, parentheses, asterisk parentheses star from app user.
App user. Give me a second. I think I screwed up again.
Yeah.
Ah, meltdown. Let's try that again. Select count from app user. Is that right?
Yeah.
There we go. 481. Good. How many app users have the first name begin with R? So it's asking me, hey, count all of them, but only the ones that have a first name starting with R. We can start from the last command, actually. Select count star from app user. Where? What?
First name, like, or you'll have to do parentheses R or R parentheses or R correction, R percent symbol. What's
Okay.
that? Well,
Yeah, it's something very close to that. See if we can get it. Where first name equals single quotation marks, right? It starts with an R. Can we do R? Was that money sign? Is that what that was? Something like that? Does that work? How many app users have the first name beginning with R? How confident are we that that's the right answer?
I don't think that's right.
All right, how would we check?
Just look at the database.
Okay, let's try. So select star from app user. Let's look at everything. Start scoping it out. Yeah, let's go. Okay, here we go. So first name, we got that column right. It is first name, right? Does anybody start with an R here? There's at least one. Rosella, right? So we know that that is wrong.
Let's try take away the equals R and do like, or just take away the equals and just do like in place of equals.
Like this?
Yeah.
Nope.
Capital R, I'm sorry.
It's not going to make a difference. I don't know. Let's see. Yes, that made a difference. Right? There's 26 of them. Good job.
can
Right.
you try it again with equals R, but capital?
Yeah.
Yeah, that probably worked too. Nope, nope, it doesn't. Why not?
What do you
Oh,
notice here about this?
well, what if you put a space between the equals and the R and first name?
A space here, like that?
Yeah, yeah, like that. No, okay.
What
That's
does
weird.
this teach you here? I know we have a couple questions still, but what does this teach us about case sensitivity within this specific terminal?
Not very forgiving.
Yeah, it's not very forgiving, but remember when it's first name like or R, it looks like within the quotation marks, capitalization matters.
Hmm.
Keep that in mind. Maybe there's a flag, like a global case insensitive flag. I don't know, don't recall, haven't done SQL in a while, right? But that's probably something you should probably look into. We know that the commands for SQL are case insensitive, but once you get to a string comparison, they appear not to be. Keep that in mind, okay?
Yeah.
Go ahead, Art.
You know, it'd be interesting, is if we can do like and or, so capital R and or small r, because what the brought that to mind is when you're talking about Facebook and people are entering their information, there's no guarantee that they're going to start their name with a capital letter.
Yeah. Yeah, you could definitely do that. Yes, that's also an option. Why is this not working? Okay, cool. All right, so I'm going to let you guys finish that. Try to do it just off the dome. See if you can. These are pretty easy. But then the second one, this is actually one of my favorite activities. I did this one a lot back in the day. I think I've forgotten most of it now, but this is a really awesome activity. trying to literally do all of these. It starts really easy, right? We're going to work through a couple together, right? So let's go through the first one. It literally just teaches you the querying language, and they get harder as you go. So here we go. The example uses where clause to show population France. Not the string should be in single quotes. Modify this to show the population of Germany. What do we have to change here?
The France to Germany.
Yeah, that's it. France to Germany. And how this reads is, hey, select the column population from the table world where name, that specific column value equals Germany. And then you submit. Boom, look at that smiley face. That means I got it right. All right, moving on. Checking a list. The word in allows you to check if the item is in a list. Very similar to Python. The example shows the name and population of countries. 4. Show the name and population for Sweden, Norway, and Denmark. What's the only thing we need to change here? This is the command. We just need to edit it. At first, they give you the command and you just have to edit it. As you progress to the challenge, you're going to have to write it all yourself. So what's the only thing that needs to change in this one?
Countries.
Yeah, the countries, right? That's why I copied it earlier. It's not asking about these, it's asking about these, right? And here, obviously, it's not going to be able to read the and, right? So that's just comma, and I copied poorly. There's another quotation mark there. Right, now submit. Boom, got it right. Just the right size. Which countries are not too small and not too big? Between allows range checking, range specific, inclusive of boundary values. That's really important to understand, inclusive of boundary values. Typically in programming, loops are what?
Exclusive.
Exclusive, yeah. So this is important here, important distinction here. All right, so example below shows countries with an area of 250,000 to 300,000 square kilometers. Modify it to show between 200,000 and 250,000. So what needs to change here?
Just the parameters between.
Yeah, 200,000 to 250,000, right? And it's actually still not quite right. What are we missing still?
Semicolon.
Yep, semicolon at the end. You would try to submit it. I wonder if I'll let you. You're missing a semicolon there, though. There you go. All right, so between, and then you can give it 2 values, right? And these actually get really progressively more complicated. Towards the end, they get pretty challenging, right? Where they different kinds of joins, and then like combining multiple queries into one. Go ahead, Art.
I think I'm missing something here because this number 3 looks very similar to number 2, just switching out countries, but we're accessing different columns. So I
Yeah.
think my confusion is coming is like we had to specify we want like this name in first name in the previous example. So why aren't we addressing the column names here?
We are, but the order is different, right? Name and area are the columns, and we're really just interested on the column values. That's where the between comes from. Where here, we don't care we do care what the columns are, but we're specifically looking for name and population only in these 3 countries. Where here, we don't care about the countries, we just care about the name and the area being between these numeric values. Small nuance.
Yeah, okay, I got it. Okay, thank you.
Yep. And we'll do one more for the sake of posterity. Select quiz. Nah, let's go to the next one. This is here's the next one. All right, reading the notes below, observe the result of running this SQL command. to show name, continent, and population of all countries. So this says select name, continent, population from the world. I'm guessing the table is the world, right? Submit. That's right. Large countries. Select name from world, right? So give me the column name from the table world where population is this specific population, right? I can submit it, and only this one fits fits the criteria. All right, so this one's a little bit harder, right? It says per capita GDP. Give the name and the per capita GDP for those countries with population of at least 200 million. All right, let's try to write this one together, and then I'll cut you loose on this. How am I going to find this? Try to see if you can just do it from memory.
Maybe we start off select name from world.
Select name from world. Great start. Let's run it, see what we get. All right, we didn't get the little smiley. That means it's not right, but this is correct. We can build from this. All right, too few columns. It says we got select name from world. All right. Given the name and the per capita GDP for the countries, what other column do we need?
Population.
Yeah, we're going to get to that though. We need, it says too few columns. We're missing a column. Which is it?
Per capita GDP.
All right, so I don't know what it looks like, right? Is there, can I go up here and look at it? Per capita GDP, just called GDP. There you go. I was just impatient, didn't look carefully. All right, so that's called GDP. Cool. The column name is called GDP. Okay, so give me name GDP from world. This is not quite right, but gets us closer. All right. So give the name and the per capita GDP for those countries with population of at least 200 million. All right, now what? We have the name and we have the GDP, but we only want the name of the country and the GDP if they're what?
At least 200 million population.
Yeah. So where do we go from here? How do we finish this? Really only a little bit more.
Where population greater than 199 million and 199,999,000.
Is it greater than 199.99, right? 999. That's 200,000. That's 200 million.
Could you do less than equal to? Is that syntax in this?
Yeah. Yeah, you could have. But I didn't want to do, I wanted to punch in all the 9. All right, is this right? Wrong answer. Some of the values are incorrect. Give the name and the per capita GDP for the countries with a population of at least. Okay, what are we missing here? This is pretty close, though. We're very close. Look at the bolded per capita GDP. Do we have per capita GDP?
No, we just have the GDP itself. We need to do a calculation for the to get the per capita.
Okay, how do we calculate per capita GDP? Per capita just means per person. So you take the GDP and you what?
Divided by population.
Yeah. That's how you get per capita GDP. Okay. How the heck are we going to do this in here?
Is and syntax?
Yeah, we could do that. but we don't need that specifically right now. What do we need to really think about here? We need a column with what?
So
Could you? Oh, go ahead.
Go ahead, whoever that was.
you do GDP divided by can you do GDP divided? What is there a divide?
Yeah, it's just normal divide, but yeah.
Okay.
Divide by population.
Population, yeah.
Okay, right.
Yeah. Uh
Let's do, how about this? Let's do name GDP, but then let's do GDP per capita, right? And that's just
mhm.
GDP, just like we talked about, by population.
Uh-huh.
And we actually have to assign it a column name here because it doesn't have one.
Okay.
So here we go. Look up here. There is no GDP per capita, right?
Right.
That's the original table, but that's fine. We can call it, right,
Mm-hmm.
as per capita GDP.
Okay.
GDP from world where population is 200 million. Something like that.
Yeah.
I can't spell population. Population. All right, let's try that again. I keep doing Command S to save it, but we're not in a file. All right, what's the issue here?
Got too many columns.
Got too many columns.
Mm-hmm. So can we just take away the GDP part and just do name and GDP
Per
divided?
capita?
Yeah.
Yeah, try that. Boom. Hero.
All right.
Notice that per capita GDP, it took the name that I gave it. It was known as a view. You can create ad hoc views with C, right? That's an ad hoc view that's being returned to the user. Does that column actually exist in the database? No,
No.
it doesn't. I created it here. Have you noticed it? That was supposed to be GDP. It's GPP because again, another typo. Alrighty, I can stop sharing. Boom, 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 boom. Any questions on challenge 1 or challenge 2?
So challenge 2, is there any, are we just going through, do you want us to actually do the quizzes for each, I guess, section?
Yes.
Okay.
I would do challenge 1 first because you're still relatively new to it. You pretty much just watch me do it. If you haven't done it already, like in a YouTube tutorial before this or have seen it before, this is pretty new to you. So practice, do the challenge 1. We'll go, I'll bring you in a little bit later to go over 1 and then how far you've gotten on 2. The best advice that I can give you is actually that SQL school. That's a really good class. Try to memorize as many of the commands as possible. But the other thing I want you to practice outside of those 2 challenges is getting into your Linux shell and connecting to the PSQL server. That's kind of a mess. If you noticed, I was kind of fumbling through it. I couldn't remember my commands. I'm used to doing Control C, Control D to get out of a Bash terminal. I'm not used to going into a Postgres server. I remember kind of the commands, right? But for you, it's going to be really important that you're quick with it, especially when you get to your personal projects and your group projects, because you're going to be doing a lot of that. You're going to be dropping tables. Right now, we loaded a bunch of information from a repo, right? You could even practice creating a new table or 2 new tables from scratch and adding information via the terminal and then showing them in the terminal to see if you added it correctly. because you're going to be doing all of that with your personal project,
Okay.
right? And anytime you, I don't really kind of want to get into it, but anytime you change the schema of what your database looks like, and this is something we'll cover on Saturday, right? You're going to have to drop the table, create a new one, blah, 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 repopulate it, make sure it's going good. Then you realize part of your application doesn't work or you're not getting the information. You're going to add another key to your database. You're going to have to drop the old table, create a new one, repopulate it, check it again. Make sense?
Mm-hmm.
And if you're asking, this is going to become somewhat pretty tedious. And if you're wondering, yes, they have a bunch of nice GUIs that does it for you. But it's difficult to understand what a GUI does if you don't understand how to do it kind of from the ground up. It's hard to kind of teach past an abstraction if all you see is a GUI. Any questions about one or two? Sorry, I just kind of rambled there for a second.
I kind of have a question in general
Yeah.
about this. So, we in the assessment we were querying CSVs with Python, and then recently we're querying APIs with JavaScript. In what situation do we use? Is this called SQL? Is that what it's called?
Yeah.
When do we use that instead of Python or JavaScript, or like, what's the purpose?
That's a really, really good question. The real answer is you don't really use raw SQL to query stuff on the job. That's the real answer, really. The slightly longer, more winded answer is that you really need to understand the basics, how these things work, because these we have a limited number of rows in querying. If you don't understand this, it's really difficult to build your knowledge on how data warehouses and data lakes work and optimizing queries. And we haven't really got into like atomic storage and having 1,300 people trying to edit the same column on your database, and how does that work? Like that's the truth. You know what I mean? Think about this way. You're on Facebook. Someone drops a fire post roasting one of your nemesis. You can't reach for that heart emoji fast enough. But you're not the only person that hates this dude or girl. And 10,000 people in your community hit that heart emoji at the same time. What's the count? Who pulled that number from the database first? Does someone add to it when the number was behind 800 likes? How does that work? Make sense? So to answer your question, hardly never, honestly. But then I told you, I gave you an example of PL SQL. Then you'll start using like an offshoot of SQL to actually write code, right? And PL SQL is exactly what it sounds like. It's a combination of Python and SQL. And you use that to query information or offshoots of that or abstracted layers on top of raw SQL. So you're not using raw SQL, but your applications are using raw SQL. Right? And you're writing those. And if you don't understand how the schemas under the hood work, or how those values are populated, or how they're stored, or how they're hashed, it's difficult to kind of build off of. Does
Got
that
it.
help? Sorry. I always try to give you kind of a macro view of the world. It's like, oh, I give the example of, and this is the last rant, I promise. I gave you the example of HTML. No one writes raw HTML. No one writes raw CSS. Eventually, you'll be introduced to like Tailwind CSS and stuff, and you'll use a lot of those libraries that do a lot of the heavy lifting for you, right? But when you start using those libraries and importing things, and then you realize that there's like a weird edge case that you can't fix, right? It's going to be hard for you to fix it if you don't know exactly what that library is doing. Make sense? All right. Enough ranting for today. Take a 15-minute break. Get back on here. This time I won't forget to open the breakout rooms. I don't know if you remember last time I forgot to open the breakout rooms. All right, I'll stop. Resume recording. Okay, so before we went on break, how many app users are there? We got that. How many app users have the first name with R? We also got that. The first 5 users sorted by last name. We didn't get that. That is a simple what? gonna make this bigger. Enormous.
Last name and limit by 5.
Select star from app user.
Mm-hmm.
Say that again. What was the last part?
Looking for well, actually, I think I did select last name from app user, and I limited it to 5.
Well, we want to order by last name, so it's not quite right.
Yeah.
Okay.
I did select parentheses. Hold on. Let me get it right. Got to go down here. So I did select, actually, I did select concat parentheses first name, comma, empty space or whatever, last name as users from app user, ordered by last name, limit 5.
That works. Except what's the issue with your answer?
It only get well for it only gives the first name and last name sorted by their last name.
Yeah, and it's asking for everything. So you get
Okay.
less than necessarily what they're asking for.
Okay.
And depending on the use case, that could work. All right, but no need to go that fancy. A simple select from star app user order by last
Mhm.
name does it alphabetically. Limit
Yeah.
5. Limit 5, right? I
Right.
think. The
Oh,
mistake was
underscore last name.
Yep. There you go. So that works.
Don't
Q to
we
get
want-
out.
Don't we want the first 5 users in the table though? So like, wouldn't
No,
we have
we want the first 5 users ordered alphabetically.
Okay.
Sorted by last name. Now, it's not very specific here, but it should have been sorted alphabetically or something like that. Right? I mean, sorted by last name, starting from Z. I mean, that could work, right? What is the average mileage of a car inside of that database? Is a simple what? That's actually wrong. I'm looking for average, right?
Yeah.
Average of what?
mileage?
Mileage.
Mileage. So it's a simple just average of mileage
Mhm.
from car. It's just an aggregate function. There you go. 72,000.
Yeah.
So that was what is the average mileage of a car with 3 or more previous owner? This one's a little more complicated. What is it? Clear. Make this bigger. Make this okay. So this one is a little more complicated. So the thing is the same. The aggregate version function is just average of mileage. Mileage. I can never spell that right. From car, and then it comes with a condition that what?
Previous owners.
That's it. Where previous, I haven't actually looked at the table, so I'm guessing just previous owners, right? Everything's underscore.
It's number of owners.
Number owners
Mm-hmm.
Number of owners.
of
Yeah,
owners
number
like that.
of owners. Mhm.
There you go. Number of owners equals 3. And if you don't know what it is, you could just literally list all the elements and look what the column's called, right?
Yeah.
Select average. That looks to be right.
Yeah, that's what I got.
Okay, perfect. So then it goes, what is the average mileage of a car with 3 or more previous owner manufactured? This would be almost identical, except for what?
You're doing the manufactured after 2008.
Is the word manufactured?
Manufacturer.
Oh, go ahead, Joe. I'm sorry.
Manufacturer underscore year. Yeah, no, you're right.
Manufacturer underscore year is greater than 2007?
Greater than 2008.
Yep. Greater than 2008. There you go.
Yep. That's what I
That
got.
just, the only difference is 2 conditions, right? This and an
Mhm.
and, right?
Mhm.
What is the average mileage of a car with 3 or more previous? Oh, we already did that. How long is the longest model name? Okay, this is an interesting one. What do you need here?
You need to count the model names. Count the amount of characters in the model name.
Okay. So it's select what am I counting here?
Select, let's see. Look at the model ID, number of owners. Hold on one second.
Model.
Yeah, model.
Oh,
select.
car model.
Yeah, car model.
Okay. So select what from car model?
Select model.
Model from car
Mhm.
model?
Mm-hmm.
And that's gonna give me what?
That's gonna give you all the models.
Yep. All right. So that was right. It gives me all the models. And now I'm looking for something pretty similar. I'm looking for the max length, right? There is a max aggregate function. I know that, right? But
Mm-hmm.
what specific property of model am I looking for?
You are looking for somehow getting the length of that.
It's just the length, right?
Mm-hmm.
It's just the length of model in terms of characters. And it's a double function here from car model. And that should give me the longest model, which is, I don't even know, Chevy or something, whatever. It's 12 characters, whatever that is. Right?
Yeah.
And I can go up here. And one of these is 12 characters. It looks like it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. Nope, not that one. Suburban. Huh?
Land Cruiser.
Land Cruiser. Here we go. This one's not in here. Return the model name. How do you do that? That's not in here. Just made that up.
Select model from car model. And then I did order by length model. And then I don't know why I did descending limit 1. I guess just to get the top one, the top one there. I guess we
Okay.
could
All right, let's try that again. Select model from car model where what?
select model from car model, order by,
Order by.
yeah, length
Mm-hmm.
model is the
Yep.
argument. Descending DESC limit 1. Or DESC, not full descent. The full word is not there.
See.
DESC.
Limit.
Limit 1. Yeah. DESC, I think, is the actual
Okay. DESC.
yeah.
Mhm.
Yep. Excellent. 12 characters, yeah. Pretty good, man.
Mhm.
Is this
But
the
I didn't get the count. I read the freaking thing wrong. So I got this, and then you were like, get the count. I was like, oh shit. Whoops.
This is a fantastic way to do this. You could have easily just pulled all of them and got the top one, right? But you limited it to one, so you knew it was going to be the longest. Good. That's a great way to do that. That might be the best way to do that, actually. Nice job. How many users live in Chicago? So we're going into app user.
I
What is
think this
this?
user profile, isn't it?
Wait, say that again?
I think this table is the user profile table, right?
No, I'm in the cars DB here. So if I do DT, I can go into any table, and I'm guessing users is where?
Yeah, I had it under the table's user profile under cars. App
Okay,
user doesn't have that one.
perfect. Okay, so we're going into there. So we're going to select, I'm just going to start it off, select star from user profile. Now, how do we amend this? So we want users. Is that the column name?
Which question? We're on how many users live in
Yeah.
Chicago?
How many users live in Chicago?
It's you are looking
I
for
can do.
the
users. And if I don't know what the column is, I can just do select star user profile and look.
Mhm.
Is
Yeah.
users street name, account ID? Let's look at the columns. Wait, what's going on here?
Yeah,
Yeah, it
users
doesn't
not
have users. It's yeah.
All right. It doesn't have users.
Hmm.
Okay, cool. That's fine. I can do star then, right? Because every row is a user. All right. So then I just have to do what then?
Uh, you want
How many
you want.
users live in Chicago? It's just a simple
Okay.
sum, right?
Hmm.
Can I just do sum of star from user profile
Where equals Chicago? Where city equals
where
Chicago?
city equals Chicago? Is that right?
Yeah.
I don't know if that's right, actually. Let's
mine
look.
threw it when I did that. Yeah.
All right, so let's look at it again. That's because city is lowercase.
Oh, okay.
And where's Chicago? Chicago is right, though. Capital
Hmm.
C. Okay, let's figure it out. All right, so city is right. That's a column name. Chicago should work. All right. All right. So this is what we just called sum of everything. So that's not going to work. From user profile where city equals Chicago. It looks like everything's right except for what?
I
I
did count
highlighted.
for this.
Yeah, should it be count?
Ah, it's not sum, it's count. I actually thought it was sum. Does it count? Does this work? Let's see. 4. Yes. I legit thought it was sum. Good catch. Count. Got it. Of course it wouldn't be sum. Sum would be aggregating. It'd be counting. Sorry. All righty. How many users live in Chicago? How many live in the cities with the word park in their name? That would be select how many users. Okay, so count star. That's fine. From user profile where city equals Chicago. Not quite. It's this last part that needs to be amended. Where what? Or user profile. It needs to be updated here. Select count star from user profile.
You
Where
can do.
um you could do I like and then quotes and then the modulus operator on either side of park.
This.
Yeah.
Try adding where
Oh yeah, yeah, you gotta have where.
where city like
Where
city.
city like.
Yeah.
Yeah.
There you go. 2. Good. And that was the last one there.
I think there was the one thing that was I also tried I like because I looked that up because I wasn't sure if this was going to be completely correct because of case sensitivity or not. So I guess
Uh-huh.
I like will remove the case sensitivity to it, but I got the same answer.
Very good. That makes perfect sense. Give me a second. I typically means case insensitive. So I like would make sense. There you go. You have a way to account for case sensitivity in the string match. Very similar to regex. I kind of like I like better because that accounts for more things, right? It could be Park Street or it could be City Park, depending if they capitalize that second P, right? Right?
Yeah.
Alrighty, that's easy. Everyone finish that now. So here, how far did we get in this one?
I didn't get to that one.
Okay,
I didn't
no
see
worries.
that.
No worries. Stop share. I'll go ahead and open the rooms back up. I would try to do a speed round on the SQL zoo and get as far as you possibly can. And then if you don't understand any, pause and retry it again and ask ChatGPT if you need to. But try to memorize as many of the commands. They'll serve you well going forward, especially again if you end up in some kind of data engineering role. Outside of that, you won't be using it that much unless you end up in that kind of role. That's all I have for you. But before I cut you loose, to answer a little bit more of Adam's question, a lot of the time, depending on where you go, you have a little GUI that makes creating the queries really easy, right? You're not always going to have that, but most of the time you're going to do it. You're not really going to do it from scratch. But it's good to understand what is possible, right? With the tools that you have. Okay, I'll go ahead and open the rooms, guys. Open. Awesome. How did we do?
Not too bad.
Good. Anyone else?
Moving along, but it's hard not to go down these rabbit holes. I like just kind of like testing what I get from switching things out a little bit.
Yeah, that's perfectly fine as long as you get the basic idea, the gist of it, and you understand a little
The
bit of the.
syntax is probably the easiest out of all the languages we've done.
Yeah, it's the easiest all for like 85% of it. Yeah, 90% even. But once you get to the last echelon, it starts getting a little wonky. Good. I'm glad you did notice that it is a little bit easier. Again, it's just a querying language. It's not a full-blown development language. All right, guys, regardless of where you got there, if you feel comfortable with exactly what you're doing, you're good. If you're not, I would definitely keep practicing. Again, it's something you're going to use a lot in this cohort because we do use Postgres for both your personal project and your group project. I want to share my screen with you and just go over a couple things that I didn't cover earlier. Share. This might be covered in another lesson in the future. I don't even know, but we're going to cover it now. Just because I kind of glossed over it and didn't really cover it. Do you guys see my screen? You
Yeah.
should see the init SQL file. Yeah.
Mm-hmm.
Okay. I think I called them models earlier. But these are, I guess, apparently now with like LLM models, like the internet doesn't like that. So it's just a schema based on every column. And I just wanted to go over it so you kind of understand where this is coming from. So this right here, line one, is creating the database cars. And in cars, it's creating a bunch of tables. And you notice that when we were querying some of these tables, now let's look at the first one. It creates app user and it has account ID. That's the serial primary key, which we're going to get into on Saturday, right? But that's the main column of that specific row where you're able to reference other tables by their primary key. Won't get too further in, but it's kind of like the link between that table and other tables. Make sense? Let me just give you kind of very loose example of what I'm talking about. Okay? Yeah? This creates a table of app user, right? And this creates a cap model. What if I wanted to search for any man that lives in Chicago that drives a Mazda that's older than 2008? I'm going to have to create a view with both of these tables, right? So that's why serial primary keys are important, right? We're going to go into it a little bit deeper on Saturday, so I won't go too deep into it. But That's what's happening here. These are the schemas for your tables. And let's look at the specific table and all of their columns, okay? First one, account ID, is an actual account ID, but also happens to be the serial primary key, right? This says it's a first name. That's a column name and it's text and it can't be null. Cool. Last name, also text, can't be null. Email text also can't be null. And what is this here?
Has to be unique, a unique ID.
Yeah, exactly. So there can't be two people in the app user table with the same I'm the greatest 2000 at gmail.com, right? It won't allow it. It's built into the schema of the table. It will reject it if you try to insert it. Yes? Just like the IRS can't insert a person, regardless of what their name is, if they share the same what?
ID.
Or
Social.
social security
Oh,
number,
sorry. Yeah.
right? Same idea. That is your government ID. Can't do it. It's unique, right? Password text also can't be null. And then it runs into some checks here for the different columns, right? Cool. You can go down to user profile too, right? Most of these are texts. Here we go. This one's an int. Number of owners, that's an integer and it's stored as one, right? Number of doors, this is interesting. It's an integer, but it defaults to 5 if no number is there. And again, it can't be null, right? And here's something interesting. Car model ID int can't be null, but it references what?
Car model ID.
Yeah. So we have a table that effectively references the serial key of another table. That's how you can link tables almost infinitely, right? In-app users, I can have Mary Miller and James Miller. They're married. They can share an address, but they can't share an email. They can share an address, but they can't share a social, right?
Mhm.
Apartment complex, they can share the main address, but they can't share the apartment number unless they're living together or married or a couple or something, right?
Mhm.
But then again, you can have 5 roommates sharing an address, but can't share a social, can't share an email,
Yeah.
right? And those are one-to-one, one-to-many, many-to-many relationship we'll talk about on Saturday. But I just wanted to go over how this is created in just a little bit of that. Okay, so you're effectively defining what each column is going to hold or can hold, right? Go ahead, Eric.
Yeah, but when we receive this information back from the query, are we going to have some HTML language in here somewhere that's going to allow it to be displayed?
Yes, but that's when you start pulling from the database and manipulate it on your backend. We haven't got there, but that's what the backend application does.
Okay.
The
All right.
backend layer of your application interacts with the database, right? So the database is queried by your backend ships it to your front end. Displays it to your user if that's what the use case is, right? Sends it off somewhere if that's the use case. Yep, we haven't got to that layer yet, but yes. Good question. All righty, we just went over this file a little bit. You went over SQL Zoo. Definitely continue that if you didn't finish it. Cover anything else that we've covered so far that you need a little extra time. We'll finish probably a little bit early, but before I let you go, I want to cover a couple databases. I don't think this has been covered, and please correct me if I'm wrong. So there's typically, roughly, really just 4 main types of databases, right? The first one is a relational database, right? It's what you're studying now, SQL, MySQL. This is a relational database talks about schemas, talks about relationships between one table and another. Relational. Yes?
Mhm.
The other one is NoSQL databases, right? Things like MongoDB, right? Where you can just store things in like a big object, kind of like a data lake type, right? You can throw anything in there, right? There is no relations. It's just a bunch of crap somewhere that you can pull if you know the key. All right. So those are the two really you could classify. Well, now there's three, but really the two big ones most people use are those. A version of SQL, a version of a relational database, SQL, or NoSQL databases. Right? Those are really the two big heavy hitters. And then um, you have cloud databases. And cloud databases, the only thing that's special about them is they're quote unquote in the cloud, but they're just versions of 1 and 2. They're a version of SQL relational database, or they're a version of a NoSQL non-relational database, like an S3 bucket for AWS. Yes?
Mhm.
Right. So those are three of the main types: relational, non-relational, cloud, but cloud is just a version of 1 and 2 and 4 in just 1 second. And then really the last type of database is some kind of specialty database, right? Whether it's a networking database or a vector database for an LLM model or something like that, right? Very niche, specialized databases. So if you really wanted to break it down, all the databases in the world are one of those four. Relational, what you're studying now, non-relational, right? Like Mongo, right? Cloud, like S3, which is really just a version, right? But you also can have a relational version in the cloud, right? And then some kind of specialized database, right? Whether networking or vector or something for LLMs. Make sense? So those are typically the four big categories. Now, I'm going to give you a couple of examples. You tell me what kind of database I'm probably going to need. Yes?
Yeah.
I'm the DMV. I'm just storing a bunch of records of people that I've given license to. What kind of database I'm going to use?
SQL is fine.
SQL is fine. Perfect. Awesome. Okay. I'm creating an Instagram clone. I'm just going to host a bunch of different pictures. What kind of database do I need?
That would be a cloud database would be great for that.
Why?
Well, for one, you're using images and you're storing the images upon it. I do know that AWS has uh, services that's just right for those types of things.
Okay. Does it have to be relational or non-relational? It's in the cloud. Perfect. But it's typically a flavor. What flavor is it? So
Relation,
is it?
relation. Oh well, no, it can be non-relational. It can be.
It should be non-relational. Okay. So for an Instagram clone, an online application, it would make sense if I had a cloud database that was non-relational. Yes?
Yeah.
Okay, let me give you kind of a little bit of a hard one. Right? I'm not going to give you an LLM model because I just told you that that's a specialty, a database. That's an easy one. But let me give you somewhat of a harder one. You are creating, right, a payment app like PayPal. You're building that out and you want to store customer information, right? But this specialty app that you're building, right, also stores receipt images. So it's like PayPal Plus. What kind of database am I going to use?
I'll let someone else answer.
This is a little bit of a trick question because you're going to need what? Probably.
Is it both? Like,
Yeah, you're going to need at least two different kinds of databases. What kind of databases are you going to need, Adam?
well, wouldn't you the SQL in a cloud?
Yeah, you're going to need an SQL database in or outside of the cloud. Doesn't really matter, but you're also going to need what other type of database? Some
Relation.
kind of, yeah, well, yeah, we already said that, right? SQL is a relationship, but you're going to need some kind of like bucket or non-SQL type databases for the images. You're going to come to realize that images don't store very well in relational databases.
Mm-mm.
And I gave you an easy one. I could have given you 30-minute long videos. That's not going to work for a relational database. Here's something slightly different. What if you're building an app like Instagram that uploads a bunch of images, right? But you also need to be able to sort, filter, and identify by the metadata of the image, when it was uploaded, by who it was uploaded. In that example, you run into something very similar, right? So you're going to have some kind of architecture like user data for someone and some kind of SQL database, along with all the images, metadata that that person has uploaded, right? With probably pointers or URL strings to where they're being held in some kind of NoSQL database.
Yeah.
That's probably something along the lines of what YouTube has, because they're storing a bunch of video content, right? So that has to be stored in some kind of non-relational database. But all that metadata and how it's searched, that's some kind of specialty database and probably a SQL database back there to keep the users. So those guys are running minimum, and I don't know, I've never worked for YouTube. They're minimum running at least 3 or 4 different kinds of specialty databases to get that platform up. Because all that data is different and they can't be stored in the same way.
Mm-mm.
It won't be optimized that way. So I showed you how the different schemas in Postgres can point to another table, right? They can also easily point to a URL path or a foreign key in a different kind of table that can be used by your backend. For example, if you had just a mere URL with all the parameters passed in, stored in a SQL database, that could be some kind of pointer that gets sent to the backend. The backend queries the S3 bucket, pulls the image, sends it to the user. Pretty common architecture. Make sense?
Yeah.
So a lot of this won't be as clean cut as, for right now it is, right? You're building a very small application with a little Postgres, cool. But just know that when you get to the job, you need to understand these small components very well, because it's very rarely going to be clean cut, one database, we're good to go, right? A lot of the times it's going to be different components needing different kinds of databases all working together, right? To get the product that you need, right? And a lot of the decision making really just comes down to money, right? If you're running, X database, but it's cheaper to run it on this one, it's cost effective to re-architect part of your application to save millions down the road, you're going to do it. Make sense?
Yep.
There you go. Any questions about the the 4 main categories of databases? And I use main categories loosely, right? Because you notice the category 3 cloud databases, they're kind of like 1, 2, and 4. They just happen to be in the cloud. What's the advantage that cloud computing has? Really, the number one advantage it has over on-prem.
Cost.
Not necessarily. People liked it, and a lot of time is cheaper because what do they call it? Economies of scale. But let's
Much easier.
say, go ahead.
It's much easier to update.
Yeah, it's much easier to upstate, but you're missing really the crux of it all. Both of those things are right. I'm not saying that they're wrong, but really, what's the thing about that really sets it apart? The one thing that really on-prem can't compete with.
Oh, well, you have more control with the proximity to the users. Like you can
No, you can get as
or
close as you
band
can with cloud computing.
Is it just the fact that it's not on your machine? It's not your
No,
computing?
you're missing the crux of the whole thing, right? All those things, yeah, maybe it could be cheaper, maybe it's easier. When I used to work at DRW, they had a lot of the machines on-prem, right? They actually built the offices around the building, and
Mhm.
the servers were in the middle, right? With like glass, floor to ceiling windows. It was beautiful.
Mhm. Is it
Think about it. What does it really excel at? The ability to do what?
the ability?
Ability to scale, guys. It's the
Mm,
one thing it can't compete. No thing can compete against that. It can scale, right? So if I was running some kind of world championship of Halo 3, right? I got 30,000 active users and we're running a live game or thousands of live games, right? And scoring points somehow, right? It can scale from 2 users to 3 million
mm,
if that's what it needs and scale back down,
yeah.
right? No on-prem can do that. It wouldn't be cost effective. Make sense?
Yep.
So just a little bit of information on databases, just database architecture that eventually you will see. That's all I have for you today. There's probably about 24, 25 minutes left in class. Please continue working on SQL or just take a break or just relax for the evening. Any last minute questions about today, about SQL, the querying language, or databases in general?
Nope.
All right, dudes, have a wonderful day. And I'm not going to say that annoying thing is like, oh, I'll give you 10 minutes back. I hate that. They always give me like 5 minutes. What am I going to do in 5 minutes, bro? Anyway, enjoy your evening, guys.
All right. Take care, everyone. Bye.
Thank you, Garo.